The new OWASP Top 10 is out. That means there are 12 categories of security problem you need to know about. Yes, 12 in the top 10. I've linked to a video for the first 10 in the OWASP Top 10, but now let's see 11 and 12. We'll start with the second one first because it makes sense. You'll see why when we get to it. Number 12 is memory management failures. In lots of modern programming languages, memory management is less of an issue. It's much harder to hit memory problems like overflows in languages like C#, Java, and JavaScript. The most common issues happened in languages like C++, where developers have a lot of control over how memory is handled. Typical memory safety problems include using memory before it's been properly allocated, accessing objects after they've been freed, use after free, and writing more data into a buffer than it was allocated to hold, buffer overflow. Modern languages do still have some problems though. For example, it's possible to use up all of the available memory by allocating variables in loops, or by allowing large numbers of requests that both use lots of memory at the server and are time-consuming. One of the OWASP recommendations, if you're using a less modern language, like C++, is to move to a more modern language. Have you actually migrated from C++ to avoid issues? Let me know what language you moved to and how it went. If you can't do that, then there's a lot you should be doing. Address space layout randomization, data execution protection, and structured exception handling override protection are all common options that you can set. Modern languages often do these by default. Input validation is important to catch things like data that'll allow buffer overflows. You'll also want to use memory-safe libraries wherever possible. Number 11 is lack of application resilience. That ultimately means if your application is given stress, suffers failures, or is given edge cases, can it recover gracefully? If all or part of it breaks, then the result can be denial of service, data corruption, sensitive information disclosure, or even bypasses of security controls. Why did I do this 1 second? Well, we looked at poor memory management first, and that is one of the ways an application can lack resilience. So entry number 12 in the top 10 is actually part of entry 11 in the top 10. If this is useful, like, subscribe, maybe comment if your brain hurts too. Defenses for lack of resilience mostly focus on rate limiting, so not allowing too many requests to overload your application. And input validation, so odd data can't create unexpected outcomes. Input validation really is a hero when it comes to security. You might also want short timeouts for server-side processing, load testing to find problems before someone else does, making good use of asynchronous calls, and good monitoring and alerting when anomalies are detected. That's it for the last 2 entries in the OWASP Top 12. Yeah, the OWASP Top 12 just doesn't have the same ring to it. Let me know your thoughts below.